here I'm introducing debugger.html. And the Mozilla Firefox DevTools team, they figured out they need to do something. So they're rewriting the whole DevTools suite from scratch using modern web technologies. And this has been going on for a little under 2 years now. It's using React, Redux, Webpack, Babel, and more community-powered tools to develop the debugger. And it's called debugger.html since it's just an HTML implementation of the debugger's user interface. That's it. So let's talk about your framework-driven code. And remember this? Let's see how we can cater for this if we shape our own debugger. So first, I want to install my debugger. And what I'm going to do is I'm going to debug a to-do app. Yeah, I know, it's corny. It's going to be great. So I have a little to-do app. I'll have a little list here. Make vanilla pudding. Put in a mayo jar. Whoops. And eat in public. Now I'm going to install the debugger. And the way it works is I open up my terminal. And all I need to do is really git clone the repository. That should be fast. I do yarn to fetch all node modules from the world. That should be fast as well. And then I do yarn start. And boom, I have a Webpack dev server serving it at port 8000. I can go to localhost 8000, which is exactly what I'm going to do in my video in about 2 seconds. I open up another tab. And I'm supposed to be seeing the debugger right now. However, I'm not seeing the debugger. I'm seeing what we call the launchpad, because every time we run the debugger outside of the actual Firefox DevTools, we need some way to say, you know, what am I going to debug? And this is what we call the launchpad. So I'm going to choose this backbone to do MVC application. And let's see what happens when this is a backbone jQuery application. So I set a breakpoint. I do something in my web application, pause on the breakpoint, and then I'm paused. And you can see that on the call stack, there is a group of stack frames that says Backbone, and it has the logo of Backbone, and it's collapsing and expanding. So we do this for a lot of frameworks, and there's actually a ticket, a GitHub issue, like tracking all the logos. I was looking at that, and I thought it also deserved a bit of more information. So how many frames are being collapsed within this? And so here's what I mean. So just yesterday, I finally pushed this code, and it was merged into the debugger. So I added these lines that say, you know, how many items. There's 2 in the upper one, 7 on the lower one. So just to help out understanding. And the code to do this was really easy. It was, you know, the information already exists. All I had to do was add this badge, which I wrote down to React component, and the information is already there. So it's really easy. Now, what about your transpiled code? So not a lot of things that I want to show you on this aspect, but we do JS6 syntax highlighting. And we can do more syntax highlighting for other stuff. I just wanted to show you that. And the way we do it is we use CodeMirror for the actual code editor. And all I need to do is find out if my source is JS6, and then return JS6. So CodeMirror, I tell it, you know, it's JS6. It highlights everything properly. So that's really nice. And though it doesn't work as smoothly, so there's an issue about it not working that smoothly. And luckily enough, there's a contributor who has claimed this ticket. So what's really nice is we have this little GitHub bot that you can do /claim, and then you get a response saying, thanks for claiming. You know, here are some links, getting started, contributing, developing. You can reach out on Slack if you want some help. Thank you very much. So if you are busy, feel free to /unclaim it. It's perfectly OK. So as for your bundled code, also not much to talk about there, but we added this. A lot of people are bundling through Webpack, and so we added the Webpack logo to the actual sources. This clicker is not my friend today. So yeah. So just the Webpack, to remove cognitive load from the developer who's looking out, where is this Webpack folder? All right, let's talk about obfuscated code. And this is a little more near and dear to my heart. So on the left side, you have your obfuscated code, which is what the actual web application is running. And the right side, you have the source mapped source, which is what you wrote. And you would like to debug the right side. And this is possible through source maps. But I want to tell you a story about mapped expressions and what I had to do with it. So lately, Jason Lasser, who is the project's lead developer, tweeted something like, "Hi, debugger aficionados will love this PR by Yuri Delanik." And the debugger can now map minified variable names onto original variables. This means scope and preview look great, and I'll explain what that means. Next up is watch expressions and console mapping. This feature touches AST's source maps and JS scopes. What's not to love? Stop by if you're intrigued. And indeed, I was intrigued. So let me show you what this means. I have this little to-do app again. I have my to-do list, buy a parrot, teach parrot to say, "Help, I've been turned into a parrot." Then I want to pause on the point where I'm adding a to-do. And now let me enlarge this a little bit so that you can see. And if you'll see, when I'm hovering over the action keyword, I'm seeing a full evaluated preview. And also in the scopes panel, I can see what it means to, I can see the action being evaluated properly where all the variables in the scope. However, when I put in watch expressions and write action, that's unavailable. And when I write T, it does get evaluated, which is weird. And what's actually happening here is the debugger frontend telling the web application, "Hey, can you evaluate action for me?" And the web application goes like, "Sir, there's someone here trying to evaluate action. I don't know where that is. Just tell them it's unavailable." "OK, it's unavailable." Then the debugger goes, "Ah, shit. You know what? It's T. Can you check out T for me?" And then the web application says, "T. Yeah, that's cool. OK, so T it is." And so the debugger figures out, OK, next time I really should send T in advance. Now, the code for this, the erroneous code, is embedded in this little function called evaluate expression, which accepts the expression that the user actually typed. So the input is action. But what it does, or did rather, I'm going to sort this out, so is just send that over the wire and ask for action. And that's bad. So what could be done, and what I did, was just leveraging some community work cool stuff and adding a snippet between those lines saying, is this a source map thing? OK, so could you extract all these identifiers from this expression and replace them with whatever I really need to send the web application? And that's exactly what it does. I send out the source maps. I send out the generated location, which is line number 1, column 61,500, and the input, which is action. And then I get back T, which is great. I send that over. And really, so I just want to show how that works, and it works fine. So I have another to-do list, sneeze in front of the Pope, get blessed. And I want to add a to-do, stop telling jokes. Probably a good idea. So I'm pausing on this breakpoint, and now I'm adding action. And please, let it work. Yes, it worked. OK, so and I can do also other stuff. Like I can add action.text. I can add action.type. I can also concatenate a string to action.text. So I can say don't plus action.text. The person is typing really slow. I'm sorry. And I can also add really complicated expressions. And remember, this is not what the web application is running. This is my source maps. But I can really add this very complicated expression and evaluate it. So how does this work? How do we replace action with T? So in the first occasion, just replacing action with T is easy, right? Here's action. OK, then replace it with T. What happens if action.text? I need to get T.text. So one possible thing to do is I can use a regular expression, but that might get cumbersome when the expressions get complicated and even more complicated. So how do exactly I replace state max ID and to do with A, B, and C? So here I turn to the aid of the almighty Babel. And the Babel is powering up a lot of stuff that the debugger is doing, because it's telling us a lot about our code. And it's doing that through the AST. So who here knows what the AST stands for? Great. So AST is abstract syntax tree, so you already know it. And just so we get on the same page, if I have this expression, the AST for this, it's a data structure representing my code. So this is an expression statement, starts at character 0, ends at 21. And its child is a binary expression with an operator of plus, also starts at 0, ends at 21. The left child is a literal with a value of don't, starts at 0, ends at 7. The right child is a member expression, starts at 10, ends at 21. And this member expression has its own children, so it has the object child, which is action. It has the property child, which is text. So this is a structure representing my code. All I need to do now is really build out an AST from my expression. Then I can traverse this AST. And if you recall the first tweet that Jason tweeted, he said, we've done the framework, we've done the boilerplate work. So what they did is they made up the bindings, the mapping between action and T. So I traverse this tree, and when I find the identifier for action, I just go to that mapping, and I get T. And all that remains to do is take this AST and regenerate the JavaScript expression. So I get don't plus T dot text. Applause would be in place. Thanks. OK, so some neat stuff with the debugger. It's really interesting. And the perks you get by working on a debugger as a web application is that you can debug web applications. So you can really debug a debugger. So the topmost is what I would call debugger number 1, or D1. The next one is D2. And it's debugging the debugger. And the most interesting point in the debugger's life is when it pauses, when the execution stops and all the data comes to life. So I'm going to do this a few more times, and I'm going to pause at the point where the debugger pauses. So here's D3. I'm adding a breakpoint at the paused.js file. Just when the debugger pauses, I'm going to do also D4 and stop there because I have just 7 minutes and 40 seconds left. Now, are you ready? We're going to get into a little pause party here. So I'm going to add a to-do. So how do you convert a JavaScript bug? You console it. Yeah. Oh, yeah, I know. So we're pausing on debugger number 4, and we have the frames. All these frames are the stack frame for debugger number 3, D3. And I'm resuming execution and pausing on D3, which suddenly comes to life. And I'm resuming execution and coming to debugger number 2, which is coming to life now. And here I'm going to step over a few times. And you can see in debugger in D1 that it's not yet showing all the information. But the second I step over dispatch here, it suddenly shows that stack frame. But the watch expressions don't show up yet, and that's because I haven't executed the line that actually evaluates the expressions. So if I do that, I suddenly see it. So I'm really hacking on the debugger here, doing my little inception trick. Never gets old. Always fun. And then I resume on D1, and my web application is done. So by now, hopefully, you see that it's not out of reach to contribute code to this application, just web application. My first contributions were about CSS changes, and slowly but surely, I started diving into the project's JavaScript code, which leads me to you. So this is really a community project. And what differentiates this debugger from, the goal here is not to develop, the ultimate canonical formal debugger where there's a product team who thinks what the right things should do. but rather the community actually doing the work to develop its own debugger, because we are developers, and this is a tool we are using. So all the features that we want to push are really there for us to push. And anyone can help, really. It's about styling, writing CSS. It's about writing code, either React code or visualize the data however you want it. Add code for just plain old JavaScript logical code, performance optimization, writing tests, doing visual design. Anyone with a skill set can help. Now, this is a first-class open source project, which means that it's really doing a lot of work to keep the community engaged. And if you think about it, this is monumental. I think it's the first time in web history where the browser platform has chosen to use community-powered tools to build its own tooling system. And the change that this causes is, if previously this was a one-way contribution, now it's going the other way as well. And this is very interesting, because if you work on a React app at home or in your workplace, you can bring the knowledge that you get from working on the debugger, and it's an expert team of contributors, to your workplace. So it's great for your own personal growth and career. And the way we do it is by keeping communication easy with Slack rather than Mozilla's traditional way with IRC. We're managing the product in GitHub. So it's not a mirror. That's the actual place where the code is happening. So no more Bugzilla, no more Mercurial. It's GitHub issues, PRs, everything that you know if you're doing open source development. There are weekly updates, because the dynamic of being an open source contributor is you don't do it every day. You do it like once a week, once 2 weeks. There are times where you're outdated. So there are weekly updates with what happened in the project, and it's out there. It's giving recognition also for every contributor that did something that week, which is great. And there are links here so you can check that out. Tons of documentation about processes, about the architecture, about code of conduct, about welcoming, about how stuff works in this project. And there's a lot of things you can read about. Weekly calls are the place where you want to meet those people. So you're doing a lot of code-intensive work, PRs, code reviews online. But once a week, there's a chance to actually meet the team and have a chance to speak in video and discuss some stuff, which is really cool. I want to share with you the way I got people hooked up on this project back in Israel. So for the past year, I've been organizing this monthly hacking event we call the Goodness Squad. And what's interesting about it is the format, because what we do is bring in a few projects each time, and we prepare. And for each project, we bring in a mentor. And the mentor's job is to lead people through the process of contributing. So leading through code, the process, the people behind it, and the issues that need to be resolved. So people make their first steps in open source contribution, or their first step in that particular project, and they return each month. And it's really great. It's working out great. And I'm passionate about extending this format. There's a group in Ukraine which has already adopted it. And if you are interested, you can reach me out. So what's next? And so each and every one of us has something that's bugging them about the debugger. And what is bugging me is that you like setting the right place that you want your application to pause. So how many times has it happened to you that you were setting a breakpoint somewhere, you pause, and then you step over, step into, step over, step out, step into, do a few loops, and set a breakpoint somewhere else, and then you reach a state where you start inspecting all the data. Did it happen to you? Well, it's bugging me. So my goal in 2018 is to think of a debug trails feature where I can push this, and this is a full-fledged feature. Now I want you to think what is the thing that's bugging you about the debugger, and try to think how you're going to do that in 2018. So this is a call to action. Hack with us and join this team of contributors and try to see if this is of interest to you. That's it. Danke schön.